Very good morning. Today's subject of discussion is limit test for arsenic. We know that the principle behind creating a limit test for any impurity in the inorganic samples is based on the fact that the impurities present in the given compound in small or minute quantities reacts with the reagent or the reactant which we use, and it produces a colored compound give a precipitate or turbidity. And this turbidity produced or the coloration produced depends upon the amount of impurities that are present in the given sample. Higher the impurity, higher the coloration, or higher the turbidity or precipitate. And we are comparing the turbidity or coloration produced in the reaction with that of the standard solution. The standard solution is prepared by adding the known amount of the impurity in it. And if it is having lesser coloration or opalescence than that of the standard, it indicates that impurity is present in the limit of the prescribed one. This prescribed one all of the limit is given by pharmacopoeias. Today we are discussing about the limit test for arsenic. In every limit test of others, we used Nessler's cylinder. But here, in the limit test of arsenic, we are not using the Nessler's cylinder. That is one of the salient features or the unique character of the limit test for arsenic. Let us look into how the limit test for arsenic is carried out. Here, the arsenic present in the given sample is converted into arsenic gas, and this arsenic gas is made to react with the hydrogen ions. The reaction of arsenic in the form of gas with hydrogen ions, it gives an yellow stain on mercury chloride paper. And the yellow stain, the intensity of this yellow stain produced is the function of the arsenic gas. Higher the arsenic, higher will be the intensity of coloration. And this is carried out in presence of reducing agents like potassium iodide. This is the basic principle behind the limit test for arsenic. Let us look into details. And arsenic limit test, we are using a special apparatus, and we are using a special test, and this test is named as Goodzet test, and the apparatus named as Goodzet apparatus. This is giving the name to the scientist who has given this Goodzet test. Oder-Goodzet reaction. The reaction is named after the chemist who have given this limit test. What is this Goodzet reaction? Let us look into it. The arsenic which may be present in the sample may be in the pentavalent form As5 plus, or it will be in the trivalent state like As3 plus. This arsenic impurity which is present in the sample reacts with hydrochloric acid, and it gives rise to arsenic acid and arsenous acid respectively. As5 reacts with HCl and it gives rise to arsenic acid. Arsenic acid is given as H3AsO4. Arsenous acid is the reduced form of arsenic acid. The trivalent state arsenic reacts with HCl. It gives rise to arsenous acid, H3AsO3. This arsenic acid and arsenous acid are produced by arsenic by reacting with HCl. Then arsenic acid present in this sample is reduced to arsenous acid. The pentavalent form gets converted into arsenic acid. The trivalent state arsenic produced arsenous acid. Whatever arsenic acid present, we are again converting into arsenous acid by treating with reducing agents like potassium iodide, stannous acid, zinc and hydrochloric acid. Arsenic acid is treated with stannous chloride and HCl, and this gives rise to arsenic acid reduced to arsenous acid, and stannous chloride gets converted into stannic chloride and the liberation of water. All the arsenic acid, that is pentavalent arsenic, gets converted into arsenous acid. The total arsenous acid, which is formed by trivalent state arsenic and the pentavalent state arsenic, which is converted into arsenic acid, is again converted back to arsenous acid. This arsenous acid, which is formed, is again reduced by treating with HCl. We treat zinc and tin tin with HCl. We get nascent hydrogen. Nascent hydrogen indicates freshly produced hydrogen. This tin reacts with HCl and it gives rise to tin chloride and hydrogen. This nascent hydrogen, which is formed, reacts with the arsenous acid and it gives rise to arsen gas, AsH3. The arsen gas, along with it, it gives a byproduct water. The arsen gas which is produced is made to react with mercuric chloride. It gives rise to mercuric arsenide along with HCl. This mercuric arsenide which is produced is yellow in coloration. The amount of mercuric arsenide which is produced depends upon the amount of arsenic present in the sample. In turn, the coloration of mercuric arsenide, higher the mercuric acid, higher the intensity of color. Means higher the amount of arsenic present in the given sample. In this arsenic acid test, we also use lead acetate cotton. This lead acetate cotton is used as a trap. It prevents the hydrogen sulfide which is formed and reacting that hydrogen sulfide with mercuric chloride. If this hydrogen sulfide reacts with mercuric chloride, it gives a black coloration. And this hydrogen sulfide which is formed, which is reacting with mercuric chloride, gives black coloration, is interfering with the detection. And it is interfering with the test. That's why we do not want to react this hydrogen sulfide with HgCl2. That's why before this arsen gas is going to react with mercury chloride, the hydrogen sulfide which is produced, which is also a gas, may also react with HgCl2. That's why we are trapping by using lead acetate cotton. The lead acetate reacts with hydrogen sulfide and it gives rise to lead sulfide and acetic acid. And by using this as a trap, we prevent the reaction of hydrogen sulfide with mercury chloride. That's why we are avoiding this. Now, let us look into the procedure of limit test for arsenic. Before that, we are, we are told that we are using Gitz apparatus. Gitz apparatus will be like this. It consists of a 100 ml bottle or conical flask which is fixed with a rubber stopper, and this rubber stopper has a hole in which through which the glass tube is passed. This glass tube has a length of 20 centimeters and a diameter of 5 millimeter. This glass tube lower part is tapered to 1 millimeter. The tip of this tapered end will be having 1 millimeter diameter, and to the from the tip of this 1 millimeter diameter tube 15 millimeters above, we have a small orifice or a hole. This hole diameter is 2 to 3 millimeter. And here this tube is immersed such that the orifice of this tube should be 3 millimeter below the rubber stopper. Here the upper end of the tube is perfectly at the right angle and it is perfectly flat in nature. Then we use a second glass tube which is having 3 centimeter in length and which is also having 5 millimeter of diameter. The upper tube and the lower tube are fixed with the help of a spring or a clip. In between, in this lower tube, we will insert the lead acetate cotton. This cotton consists of 50 to 60 milligrams of lead acetate, or we can also pack with this cotton which is covered with a paper having 50 to 60 mg of lead acetate. What is the purpose here of using lead acetate cotton? As we have seen, this combines with hydrogen sulfide gas which is produced and gives lead sulfide, and it prevents the hydrogen sulfide reacting with the mercury chloride paper. This mercury chloride paper is kept in between the upper end of the second tube and the first tube. These two tubes are kept in place with using a clip. In between these two tubes, we are inserting a disc of small mercury chloride paper. This mercury chloride paper, what we use is having 15 into 15 millimeter of size. And here we add the solution of the sample which is may contain arsenic as impurities and HCl, and this reaction takes place The arsenic gas is produced which moves via this glass tube. The hydrogen sulfide gas which is produced is trapped by using this lead acetate cotton, and the pure arsenic gas combines with the mercury chloride present in the mercury chloride paper, and which gives the coloration, yellow coloration. And the intensity of this coloration produced depends upon the amount of arsenic present in the sample which is taken. Let us look into the procedure now. The two sets of arsenic Gitzet apparatus is used, one for test solution, another for standard solution. Now we are using the special apparatus for arsenic test. We are not using Nessler's cylinder. We dissolve this sample which is given in 50 ml of water and add 10 ml of stannated hydrochloric acid and transfer into the Gitzet apparatus bottle. In the standard solution, we take 1 ml of arsenic standard solution and dilute with 50 ml of water and transferred into arsenic apparatus bottle, and to that we add 10 ml of stannated hydrochloric acid. To the above solution taken in the Gitzet apparatus, we add 5 ml of 1 molar potassium iodide and 10 grams of zinc which is free from arsenic or which is specially prepared for arsenic limit test, to both the test solution and the standard solution. The assembly is immediately arranged with the stopper, both the test apparatus and the standard apparatus, and kept in the warm water. And at this warm condition, the arsenic present in the sample reacted with HCl gives arsenic acid and arsenous acid. The stannated hydrochloric acid converts the arsenic acid into arsenous acid, and this arsenous acid is again made to react with zinc and HCl. The zinc and HCl produces hydrogen gas, that is nascent hydrogen, and that reacts with the arsenous acid and gives rise to arsen gas. And when we have kept this arsen in the apparatus, that arsen gas reacts with the mercury chloride paper which is kept in between the two tubes, and that gives the coloration. The reaction to occur, it takes 40 minutes, and the whole apparatus is kept under the standard warm condition for 40 minutes. During this 40 minutes of time, the arsen gas which is produced reacts with mercury chloride and gives the coloration. And the coloration produced by the test sample is compared with that of the standard sample. If the yellow stain which is produced is lesser than that of the standard one, then it passes the limit test. This is how the limit test for arsenic is conducted. Arsenic is one impurity which is poisonous, and it should be kept under control. That's why this limit test for arsenic gains importance. Otherwise, it causes deleterious effect on the human body. Various reagents are utilized in the limit test for arsenic, and all these reagents which we use should be free of arsenic, and it should be specially prepared for arsenic test. How are they prepared? Will be the subject of discussion from now onwards. We prepare 1 molar potassium iodide by taking 1 molar of potassium iodide, that is 166 grams is the molecular weight of potassium iodide. If I dissolve 166 grams in water and make up the volume to 1000 ml, I get 1 molar potassium iodide. 2 molar sodium hydroxide is prepared by taking 40 into 2. 2 molar I want, 40 grams is the molecular weight, 80 grams of sodium hydroxide, and dissolve in water and make up the volume to 1000 ml, and get 2 molar sodium hydroxide. Arsenic acid standard solution contains 10 parts per million, and this is prepared by taking 330 milligrams of arsenic trioxide and dissolving in 5 ml of 2 molar sodium hydroxide solution which we have prepared, and we dilute with 250 ml of water, and 1 ml of this solution, standard solution which you have prepared, is taken, and we dilute again with 100 ml of water, that consists of 10 parts per million of arsenic. This is the used as a standard solution. The lead acetate cotton, what we have prepared, should consist of 50 to 60 milligram of lead acetate. We take the absorbent cotton and dip into the mixture of 10 volumes of lead acetate solution and 1 volume of 2 molar acetic acid. That is 10 ml of lead acetate solution and 1 ml of 2 molar acetic acid solution. After dipping, we drain off the excess of liquid by keeping in between the filter papers. And we won't squeeze it. Whatever is absorbed is dried at room temperature, and it is stored in a tightly closed container. We can also use lead acetate paper in place of lead acetate cotton, which is also prepared in the same way. We prepare the lead acetate solution and dip that into this lead acetate solution, and we dry it at 100 degrees centigrade, and we dry it without keeping into contact with the metal. Lead acetate solution, what we use is 10% weight by volume. 10 grams of lead acetate we dissolve in 100 ml of water, which is carbon dioxide free. We get 10% weight by volume lead acetate solution. Mercury chloride paper, we use smooth white filter paper which is having the width of 25 millimeter and is soaked in standard solution of mercury chloride, and excess of liquid is removed and dried at 60 degrees centigrade in the dark. The filter paper which we use should weigh to 65 to 120 grams per square meter. Stannated hydrochloric acid prepared, which is low in arsenic, which is commercially available, or it can be prepared by adding 1 ml of standard stannous chloride solution to 100 ml of hydrochloric acid. Get stannated hydrochloric acid. Stannous chloride solution is commercially available, or it can be prepared by treating 1 ml of stannous chloride solution, adding equal volume of hydrochloric acid and heat it by reducing such that it reduces the volume to 1 ml, and we filter through the filter paper, and that solution is used for preparing stannated hydrochloric acid. This is how these reagents which we use in the limit test for arsenic are prepared. Let us look into the other aspects in the coming presentation. Till then, have a nice day. Thank you.